Hi friends, in this video we are going to talk about increasing and decreasing functions and how to determine analytically if a function is increasing or decreasing on a certain interval. A lot of what we do in here will feel like a repeat of what we did in the last video about local extrema, so this will just sound like sort of more practice problems of the same type. Some definitions that I think you probably already know. F increases on an interval if having an x1 value that is smaller than x2 implies that your y value is also smaller. That means that your function is increasing. And if a smaller x value has a larger y value, then you have a decreasing function. But that's something that's really hard to check for without literally testing every single pair of XY coordinates on a particular interval, and there are infinitely many, so you can't really check for it using the definition, and that's why we need calculus. Another word that might come up sometimes is monotonic. So if you see that word, that just simply means that a function is always increasing or always decreasing. This next corollary here will tell us how to use calculus in order to determine if we have an increasing or decreasing function on a particular interval. So this is something we already know. We just have never really put it together exactly like this before. So if f prime is greater than 0, which means that f prime, the first derivative, is positive, then that means that your function is increasing on that interval, and vice versa. If the derivative is negative, then your function is decreasing. One thing to sort of notice about this definition is when we talk about increasing and decreasing intervals, we are using square brackets here. So that's including the endpoints, but the derivative does not necessarily have to be positive, including the endpoints. That interval has parentheses. So it's probably very likely that at the endpoints, the derivative is 0. So not positive or not negative, just 0. But we're still going to say that the function either increases or decreases all the way up to and including the endpoints. All right, so we're going to answer a question here that's a lot like the last type of problems we did, where we're finding local extrema using analytic methods. But then they also want us to tell the intervals where the function is increasing and decreasing. So step 1 was to find the derivative. And in this case, it'll be 5 minus 2x. And step 2 is to find the critical points. There's not going to be anything that makes this derivative undefined, so we only have to find places where the derivative is equal to 0. And that happens at 5 halves or 2.5. And then step 3 is the analysis. And in these situations where we also have to find increasing and decreasing intervals, you're really going to want to rely on this sign chart. So your critical points go on the bottom of your sign chart. These are x values. And on the top of the sign chart, we're going to be talking about the sign of the first derivative. So we want to know from negative infinity to 5 halves, and from 5 halves to infinity, is the derivative positive or negative? The easiest thing to plug into the first derivative is 0, and 0 falls on this side. So if I plug in 0, I'm going to get 5. That's positive. So that means the first derivative is positive on this whole interval. If I plug in something greater than 5 halves, like 100, I'm going to do 5 minus 200. That'll definitely be negative. And that means your first derivative will be negative on that entire interval. So that lets us say something about the actual function f then. So the first derivative is positive and then negative. That means f is increasing and then decreasing on those intervals. And the only thing left to do is sort of write it up in a more formal way. So when we write our answer, we're going to say f of x is increasing on the interval from negative infinity to 5/2. And I said we always use square brackets, but we never use square brackets with infinities. That rule hasn't changed. And decreasing on the interval from 5/2 to infinity. They also asked us to find local extrema. So if you have a function that's increasing and then decreasing, that critical point right there in the middle is a local maximum. So there's a local max at x equals 5/2. And a lot of times we need to justify these things. So the reason that you know this is a local max is going to be because at that point, x equals 5/2, f prime changes from positive to negative. And we know that if the derivative changes from positive to negative, that means the function is changing from increasing to decreasing, and that is basically the definition of a local maximum. So this is how we would write up in a more formal way our answer to a question like that. We kind of already knew this because we know something about polynomials. So we can look at that and say, I know that that's a parabola that opens downward. So even without making the sign chart, we could have said, I know it's going to increase and decrease. You could have used algebraic methods to find where the vertex of that parabola is. But most of the time, the questions you have to answer this about, the functions you have to answer these questions about are not going to be parabolas. So you're not going to have other methods. You're going to have to rely a lot more on calculus. Here's another problem that's asking the same thing, but this time it doesn't say to use purely analytic methods. So we're going to use some calculus. We're going to find where the local extrema are, where the intervals are that it's increasing and decreasing. We're going to have to use our calculators to help us out with this one, but we're still not going to just simply graph this function in the calculator and find the maximums with the calculator, because that is still not something that's allowed on the AP test. Or it's not good enough justification on the AP test. So we're going to go about the process the same way. We're going to find the first derivative. The derivative of cosine is negative sine, so this is going to turn into plus 2 sine x. And then we want to find critical points, so we're going to say what would make this function equal to 0, and that's where we run into problems. If you set this equal to 0, that's something that we don't know how to solve on our own. So that's where we're going to use our calculator. And you are allowed to use your calculator in order to solve equations. So even though it's very tempting to just go ahead and put the original function in there, that is not going to fly on the AP exam. They wouldn't accept that as good work for an FRQ. But if you're just using your calculator to help you solve this equation, you don't even have to show that part of the work. You just show that you're setting this equal to 0, and then we can just write the answer down after that. And they don't really care how you solved that equation because it doesn't involve calculus. So I'm going to graph that. And I'm going to find the zeros of this function in order to solve this. Feel free to fast forward through this part of the video while I use my calculator to find the zeros. And the other benefit of using the calculator in order to find those zeros is I already know what the signs are going to be on all three of the intervals that have been created here. So I could tell from the picture here, this is the first derivative that I graphed, that it's positive in the beginning and then it's negative in between those two zeros, and then it's positive after that. So my sign chart can be really super quick and easy. So I know that my f function goes up and then down and then up. And I could tell all of that by looking at the graph of the derivative function. So we want local extrema, and we want the functions or the intervals where the function is increasing and decreasing. So we could say we have a local max at x equals negative 1.126. Remember, we always use 3 decimal places. If you needed a y value to go along with that, remember you would plug that number back into the original function, and you would use your calculator to help you with that. Most of the time they only ask you for a location of it because plugging that number in and evaluating is not really a calculus skill. So you don't really have to test whether you know how to do that most of the time. And then we know we have a local min at x equals 0.559. If we have to justify this, this is because f prime changes from positive to negative, and this is because f prime changes from negative to positive. And then if we want to list the intervals where it is increasing, on the interval from negative infinity to negative 1.126, remember square brackets except for infinities, and 0.559 to infinity. And we can say that function is decreasing on that middle interval where we can use square brackets on both ends. This square bracket thing is a little weird because it's almost like saying that right here at this local max, at the x value negative 1.126, our function is both increasing and decreasing. And that seems odd. It seems almost incorrect. But we only talk about functions increasing and decreasing on an interval, because you'll remember from the beginning that in order to tell if something is increasing or decreasing, you have to compare 2 points. You have to know if the y value of the second point is higher or lower than the y value of the first point. So there's just no way to say if a function is increasing at a particular point or not. We only can talk about this on intervals. Even though it seems like a logical question to say at this particular point x equals 0, is the function increasing or decreasing? It seems reasonable to say you know that it would be decreasing right here at any point on that interval. But the reason that we are able to use square brackets is because that's technically not the way that it's defined. It all just kind of falls back to how individual textbook authors choose to define increasing and decreasing. So it's one of those things that's never going to be taken points off for on an AP exam if you were to put parentheses there instead. But technically the correct way to do it is with square brackets. The only time for you guys that it will really matter is when you're doing Math Excel, because they can be picky about that. But otherwise, I won't ever take points off, and AP readers don't take points off either if you use open brackets, or open intervals or closed intervals for increasing and decreasing. All right, I hope that this was helpful. Once you watch this video, you may be able to get some more work done back here with this STU practice page. And you can, even though they only tell you to find absolute minimums and maximums, if you want to go back in there and find local maximums and find the intervals where it's increasing and decreasing as well, that would be a good way to practice. And in order to check your answers, all you have to do is graph the original function in your calculator and see if you see the same things that you were finding analytically.